Good evening, good morning, everyone. This is Niladri Chaudhary, CEO of Excel Intro and the chief organizer for the largest DevOps event based out of India called DevOps India Summit. As part of our initiative, we thought that we will try and get more and more knowledge sharing sessions. And during the COVID, when we are all at home, I tried to bring as much as possible many experts and practitioners. And today we have two of them, that is Patrick and Tim. They are both from a company called Cashpoint, and their product is web test page. And I will hand over to Patrick to introduce and start off with the webinar.
Hi, so I'm Patrick Meenan. I created Web Page Test, and Tim and I have both been working in the performance world for, God, the better part of the last decade plus. And it's like what we like doing, what we like talking about. And so we're thrilled to be here talking. We're mostly going to be talking about core web vitals. It's a really hot topic these days with the search changes coming. And so it's mostly going to be focused on sort of the history of web performance, how we got to where we are currently, and some of the things to look out for. I'd say definitely ask questions as we're going along. I'm going to try and, if I can find the chat, have the chat open. Tim and I will both sort of be keeping an eye on the chat as we go along, so hopefully we can answer your questions live. If you're watching the video recording, or even if you have questions afterwards, both of our Twitter handles are up here on the screen, T. Cadleck and Pat Meenan. Feel free to ask us anything on Twitter. We'd be happy to talk web performance there as well. That tends to be one of the more active web performance communities, tends to be out on Twitter versus like LinkedIn or Slack or something like that. So most of our stuff is done out in the open, and we're thrilled to be here with you today. So we're just gonna dive right in. So how we got to where we are today, and in sort of the DevOps world, this is probably still a fairly important metric to keep an eye on. Oh, sorry. But the original sort of performance metric, if you would, for web serving was the server response time, how long it took the HTML to be served from the origin server, mostly in the days of like the slashdot effect, where you wanted to make sure your site would handle a huge spike in traffic. Do we have enough resources? This is all like pre-cloud. Can the servers we've deployed handle the load that's coming in, and how quickly can we respond to traffic? And it was a very sort of operationally focused performance measurement, much less a user performance metric. But it is still very important today. The browser can't do anything until it gets the HTML for the page. And so if you have a slow time to first byte, which is largely what server response time gets rolled into, everything else is going to be slow. And so you can't render anything, you can't get time to interactive, you can't do anything else until you get the HTML. And so if you have a situation where you have a slow first byte time, that's absolutely the first thing to focus on. And a couple of years ago, I did a quick scan of around 100,000 pages on the web. I think I was at Cloudflare at the time. And it was a little shocking that even then 20% of the websites had more than a 3-second time to return just the HTML. And for context, that 3 seconds is higher than the Google threshold for when the main content's supposed to be rendered entirely. So that's not off to a great foot. And so definitely not something to lose track of, but it's not sort of the all-encompassing metric that we'd like to have for the user experience. And so we sort of moved on from server response time as a top-line metric that we try to pay attention to. And this is sort of around when Steve Souders, working at Yahoo at the time on the Why Slow and the performance team, came out with the 80-20 rule. And it was also because Yahoo was largely focused on server response time. But when he was looking at their websites, the actual server response time was only about 20% of the actual user experience. All of the rest of the time came from the other 80% was on the front end, with the browser sort of assembling all of the resources that were referenced in the HTML, running the scripts, the style sheets, the fonts, loading the images, sort of all of the things that front end devs work on these days. And that's still the case today. Actually, it's probably moved closer to 90-10 as we keep putting more and more on the front end. And we have better serving infrastructure and more CDNs and caching and everything else. If you're not in that 20% that had a 3-second time to first byte, generally the vast majority of your time is on the front end. And so we started focusing more on metrics that were user facing and measured from the front end, from the browser perspective. Page load time, the onload event was sort of the easy first one of these, and it's been sort of a performance metric. We're trying to kill it, and it just won't die. But this is the onload event. It's when the browser has loaded all of the things that were defined in the HTML for it to load and run. All of the scripts, all of the style sheets. It's run and loaded all of the images that were referenced in the HTML itself. However, that doesn't necessarily include anything that's added or manipulated by JavaScript after the fact. And so you get into this weird situation where the page load time is a good technical metric if you're trying to understand how long it took the browser to load all of the static resources. And if you've got simple sort of content HTML pages, that used to make a lot of sense. But like this is an old version of Twitter when early in the single page app days, where the onload event was literally just the bootstrap JavaScript for the application loading. And then the application actually started running and loading and did everything after onload. So the onload, all it would be the header banner, and that's not a terribly useful measurement for the user experience. And the flip side goes as well, where really long scrolling pages, the UK Daily Mail is one of my favorite examples, where it's a massive site, and especially back in the day, and it would take 30 to 60 seconds to load. But what was visible to the user in the viewport would load in under 2 seconds. And so you'd have this huge, massive site, but visually it's really fast. And that's because it's really long scrolling. There's articles and articles, thumbnails for articles going down almost forever. And so you get the situation where the page load time can either be too fast or too slow, and doesn't really represent the user experience very well at all. So we started moving towards render-based metrics. This is around when web page tests started to add video capture and the film strip to what it was displaying. Browsers would start measuring first paint times, early 2010s, give or take. And so a lot of the browser paint timings, the first paint that was reported by browsers at the time, we were really excited about it, but it wasn't terribly accurate. And so we'd start getting, the browser would report that it painted, but it painted the white screen for the new page that it's navigating to, not the actual page content, for example. And so recording the video and comparing it to what the browser's reporting to sort of validate that the metrics you're getting are what you actually want to be getting became fairly important. But this is the start of measuring actual user experience. It doesn't necessarily tell you anything about the full experience or how good the user experience was, but it's a start. They first started to see something on the screen, and it's still an important measurement that we have today of when does the user actually see something loading for your site. We went from there and we kind of went to the other extreme as far as complexity of metrics. Speed index is still a very valuable metric in the web performance world, but it's really hard to explain to people. It ends up being the average time when a pixel is rendered to the screen. But if you look, like in this case, if you had a speed index of, say, 2200, that would mean at 2.2 seconds, that's the average time when something rendered on the screen. But if you look at 2.2 seconds in the film strip, you won't see anything changing. So you can't point to something in the film strip and say, hey, that's when this happened. But what it did was, instead of rewarding you entirely for painting something at the beginning or when all of the stuff was contented, it tried to give sites or encourage sites to paint as much of the user content as quickly as possible. And so if you had a social widget like a Twitter like button embedded in your page, you wouldn't get penalized because that only added a tiny little bit of the visual experience. But if you could get all of the rest of your content on the screen really quickly, you'd have a really low speed index. It had some fairly glaring flaws, and still does today, in that you can't measure this without video capture. And so by definition, you can't measure it in the field. It's a lab only metric. It had some rough edges around interstitials. Like if you have a big pop-up that pops up 20 seconds into the page, the speed index is going to consider that pop-up the final state of the page and not give you credit for the main content that you loaded behind it. If you have an image gallery that's rotating images, you won't get credit for the first image if the end state displays the second image, for example, and things like that. And so it's served us well, and we still use speed index to validate a lot of the other metrics. But luckily, we've moved on to have somewhat better user-facing metrics. But this was also sort of the state where we got to, instead of just focusing on start render, like in the Twitter case, start render still would have been fast because you have the banner on top, even if the main content loaded. This is around where server-side rendering became more popular, where single page apps would render on the server side to try and push down as much of the visual content, get it onto the screen for the user as quickly as possible, even if it wasn't necessarily entirely the final state. So we sort of moved on from the visual metrics into defining what the user experience should look like. What are the key milestones that we're looking to measure? And this comes out of the Chrome team at Google. Kenji, I think, was the first one to come up with the is it happening, is it useful, is it usable stages, where is it happening is sort of the first indication that something is happening. First paint, first contentful paint kind of fall into that as far as metrics go. Is it useful is where is the main content that the user came to the site to see visible for them to interact with, to consume, or whatever. That's kind of a nebulous. First meaningful paint was the first attempt at that. We've got better iterations of that, but understanding what the core user content is can be complicated if it's not an application that you control. And then speed index kind of falls into that. And then the is it usable came out of the sort of server-side rendering hydration of single page apps, where we encouraged getting so much visual content loaded as quickly as possible. We ended up in a situation where apps were then running all of the JavaScript after the visual content was displayed. And you'd end up in a situation where the app is completely unusable, even though it's visible, because the JavaScript is running, blocking the main thread, and they can't do anything until the JavaScript is all run. And so the goal was to get a measurement around at what point can the user actually interact with the application that they're looking at. And so, yeah, I mean, this is effectively what it looked like when we have server-side rendering. This is the bottom edge of a web page test waterfall, where above you have all of the requests, but down at the very bottom, starting at when the start render happened, you get a visualization of what the main thread looks like for the browser. And so here we have, at around 13 seconds, the content showed up, but then the main thread, all of those red blocks are when the main thread is blocked running JavaScript and won't be able to interact with the user. And so it'll be a really janky experience. And so as far as the SEO rankings, there's a question in chat. We'll get to that in just a second because we definitely have the 3 metrics going into the core web vitals about what you need to sort of look and optimize for.
Yeah, talk about a great segue. Yeah.
Yeah. So time to interactive was the first attempt at a is it useful metric, where it would measure the first point in time, or actually the last point in time, where the application had a blocking long task where the main thread wouldn't be interactive. So it's effectively the time after which the app is guaranteed to be responsive. Unfortunately, the drawbacks it had, since it measured the end state, was it couldn't distinguish between an app that was completely janky for 70 seconds and an app that was very responsive for 70 seconds and happened to have one long task right at the end. And so we've had years of trying to focus on time to interactive, which got people looking at the main thread, which is a good thing, but the metric itself didn't end up being terribly useful. What did come out of that that was very useful was the long tasks, the performance observer, where you can, from the browser in JavaScript in the field, get visibility into how often your main thread is blocked through callbacks and notifications. So from there, we're diving into the web vitals. I think this is you, Tim, or is it still me?
Yeah, I mean, I can take it from here. I think this was, so kind of this is where Pat was kind of pointing out with all of these new metrics, right? We've had this flurry of metrics over the last few years, and it's moving us closer towards this idea that performance is this journey, right? And if you want to keep tabs on it, a single point in time is not the best way to do that. The best way to do that is to look at it from a variety of different perspectives. And, you know, what are those key milestones from a user perspective? At the same time, as Pat, you know, noted, with all of these metrics coming out, that made it really challenging for organizations to keep up. New metrics were coming out constantly. They were being, you know, put in front of folks as like a very important thing for people to go after. But the result was organizations had a hard time figuring out which one do I care about the most? How do I prioritize? And then if a metric, you know, is superseded by something else, what do I do? So Core Web Vitals came out to try and help with that. It's this trio of new metrics. This is the 3 metrics you should be looking at from that SEO perspective, that combine with other signals to try and indicate like the quality of a good page from Google's perspective. And the idea here, again, is performance is hard, new metrics constantly coming out. So let's try to have some stability. Like, let's set some targets, set a few metrics that we know are relevant from a user experience perspective. And then the idea is that, you know, Google's only going to revisit this. I think it's like an annual process where they could potentially change things in terms of targets or what those metrics are. And if so, they give you plenty of warning. So this is, so diving right into them, first contentful paint is actually a web vital, but not a core web vital yet. Like Google has this idea of the 3 core, and then these 2 supporting vitals, which are time to first byte, that server response time that Pat mentioned earlier, probably because when server response is bad, everything's bad. And first contentful paint, which Google has suggested is going to become a core web vital in the future. First contentful paint measures the time from page load to when some piece of content, like a text or an image or a video or a background image, is displayed on the screen. And as you can see here, we've got a little bit of a code snippet underneath that sets up a performance observer. That's how you would monitor this in the field. FCP is also interesting because from a real user perspective, this is the only one of these metrics that we can get in Chrome, Safari, and Firefox. Safari just shipped support. Although in our testing, we have seen that there's a bit of a difference between first contentful paint and Safari versus the other browsers, just because of limitations in terms of the browser and how it works and things like that. So the next metric and the first of the core web vitals is largest contentful paint, which is a little bit more particular than first contentful paint. Largest contentful paint is looking again for some piece of content, but specifically the largest one based on the size within that initial viewport. So in this screenshot here, you can see early on, Who was qualified for the September debate so far is a piece of text that is the largest paint at that point. But as the page continues to load, the image comes in, and now that becomes the largest contentful paint. And so that would be the final LCP metric in this case.
And as far as the search rankings and Core Web Vitals go, this is the key loading metric to pay attention to. It's also probably the one that's going to take the most amount of effort over time. We'll get into the other ones in a second, but most of the other ones are like a checklist, a bullet. Hey, we've got this one layout shift. Let's remove it and then fix the field in general. LCP depends heavily on sort of the user population, their network connections, and so optimizing it at large is a much harder needle to move. And my guess is this is probably the one most teams are going to be spending most of the time on. The others are sort of cleanup lists.
So the second is cumulative layout shift. This is, of the three, one of the more new ones in terms of like how it looks at performance. It's a measurement of visual stability. So what it's doing is it's recording any shift that happens in the visible viewport there, where one element changes position from one frame to the next. So in this case, you can see we've got the cookie banner coming in. And so this header that was at the top in that first image there gets shoved all the way to the bottom. So these layout shifts are measured based on the size of the shift and the fallout from the shift. There's a little bit more going on, but basically, like if you're moving an entire viewport, that's about a 1 for the score. And then each of these shifts then gets tallied. Now, it used to be cumulative in the sense of like every shift over the course of the page experience got added together and it created your CLS score. So if you had a long-lived page or like infinite scrolling or a single page architecture where you technically aren't ever breaking navigation, that CLS score continued to get higher and higher and higher. But Google recently made a shift on that. Nice. That was an unintended pun. A change to that, basically. So now they're breaking CLS into windows. And so a shift window starts when the first layout shift occurs. And the shift window continues to go until there's either a 1 second gap between shifts or the shift window size reaches a 5-second threshold. That's like the maximum threshold. So in this case, you've got a waterfall from web page test, and I've highlighted each of the windows here. So instead of one massive CLS score, you're now being reported the largest window size, which I think in this case was window number 4. But basically that you get this little bit of a breakdown to help with those long-lived sessions so that it's a little bit more of a level playing field.
And the longest shift, the largest shift isn't necessarily going to always come from the one that had the most shifts, because you can have a lot of really tiny shifts that don't add up to like one big giant shift.
And then the third of the core web vitals is first input delay. So first input delay is a measure of interactivity. What we're measuring here is when a user first tries to interact with the page, what is the delay between when they take that action and when the browser is able to start responding to that input? So in the main thread example you see here, the browser receives first input at that mark. However, it's also doing a task in this case, running some JavaScript, something like that. So until that task is complete, the browser is not able to respond to it. Now, critically here, the definition is when the browser can start to respond, not necessarily when the browser has completed responding. So if that user interaction triggers another chunk of JavaScript or some styling work or something like that, all of that work is actually not included in the metric. It comes after the fact. So in reality, the delay can actually be a little bit more significant from a user perspective, which is something the Chrome team is trying to look at in terms of what else could be potentially added here or could be measured to help give a more accurate representation. But right now, the input delay is I click on something to when the browser can say, cool, I can start to do something with that click event. Now, first input delay is also unique in the other two in that you can only measure it in real user data. You need somebody to try and input or try to interact with the page. So for synthetic data, lab data, where we're controlling the environment of our tests, we use total blocking time as a proxy. So total blocking time looks at that main thread and it looks at all of these long tasks that are happening, these long running JavaScript tasks typically. And any task, anything over a 50 millisecond threshold is considered blocking in this metric. So in this case, you can see the list here that we've got on the screen. The first task takes 250 milliseconds to complete. They take the measurement of that over that 50 millisecond threshold, so 200 milliseconds, and that goes towards your total blocking time. So in this case, we end up with 345 milliseconds of blocking. Typically, like, there is a connection here between total blocking time and first input delay. You know, the higher your total blocking time, the more likely you are to have a poor first input delay score. That being said, the correlation isn't super strong, but it is the best we have currently from a synthetic perspective.
So as far as where you can investigate and work with the Web Vitals, Chrome DevTools, if you're doing local development, is a great place to get started. In the Performance tab, there's a timings chunk section, which will show you all of the Web Vitals as they happen. And it'll even show LCP candidate events as they're happening and give you details about the elements that triggered and stuff like that. You can also run Lighthouse in Chrome DevTools, and part of the performance report, it will collect the core Web Vitals. You can run Lighthouse through a command line interface if you want to automate collecting core Web Vitals. In that case, the Web Vitals that you report or that you collect through the lab, it's specific to your location where you're testing. The webdev.measure is a Google hosted version of Lighthouse. It's worth sort of crossing your eyes and squinting a little bit when you look at the Lighthouse performance reports from a hosted test, because Google will run the test unthrottled, and then it has an internal model of how it thinks Chrome would have loaded the page, and it predicts what the Web Vitals would likely have been on like a 3G connection, but it's not actually measured. Web page test will run Lighthouse as well as just collect the Web Vitals directly, and it actually runs at whatever connection speed you specify. And you can overlay the layout shifts. So like on the bottom one, you can see what content moved or got reported by Chrome as a layout shift. And the top one, the green highlighted, is when largest contentful paint happened. And you can see what element triggered LCP. There's also, if you click on the labels for Web Vitals, it'll take you to a debug page that'll give you all of the element details, the actual image URL, the styles, the outer HTML, if you want to try and figure out which element in your content actually triggered each one of these metrics. One of the more recent additions to Web Page Test is pulling in the Chrome user experience field report into the synthetic data. And so this is the place where the Chrome user experience report is the ultimate source of truth. And I know I see there's like a question about geography for core Web Vitals and variations between countries and good standard and 75th percentile. Google measures the core Web Vitals from Chrome users in the field. So anyone who is using Chrome, who is logged into Chrome and did not opt out of having history sync, will report the performance of every page they visit. And so Google aggregates those as a whole globally. It's not per region. So no matter where your site is or what demographic you're targeting, your user traffic is aggregated in a global sense, and they have the targets, the 2.5 seconds good for the 75th percentile for LCP, I believe it is. If you get better than 75% of your users are within the good range for all three metrics, you'll get the SEO boost. But so what Web Page Test displays is the field data for that URL that you tested. You have the distribution, how many are in the good range, needs improvement, and red is the poor range. So if you don't have 75% green for the core ones, ignoring first contentful paint, then there's an area that you might want to focus on. And then below the bar, it shows you what the actual P75 reported from Google from the field data is. And above the bars, you have the measured results from this synthetic test. The dark bar, the dark arrow pointing down is the first view, and the gray arrow pointing down is the repeat view. And you can see how representative your synthetic test is of the field data that Chrome is seeing to know if the test that you're looking at right now is relatively representative of what you're seeing in the field and gives you a good idea of what you need to optimize. And in this case, with the first view and repeat view kind of bracketing the P75 or being really close to the P75, it ends up being a very representative result that you can then sort of dig into and assume that any improvements you make here are likely to improve your field performance. It's worth noting, and with the search impact stuff coming out in June, now is definitely the time to get everything fixed, because the Chrome field data is a 28-day moving average. And so it can take up to 28 days for your performance improvements to be reflected in the Chrome field data. The Core Web Vitals, the Chrome User Experience Report itself is a data set that you can look at in aggregate. It also has an API that you can call to get URL-specific information. That's what Web Page Test uses, for example, to get all of the data that it's showing. Page speed insights, and I see there's a PSI question about PSI using unthrottled connections, then applies deltas to the results. Yes, so PSI runs the same hosted version of Lighthouse that WebDev measures, which runs the actual test unthrottled, and then it applies its own model and adjustments. It's called Lantern mode for Lighthouse. You can run it locally on the command line as well to predict what the metrics likely are. The more useful data from Page Speed Insights is the field data section. And this is the same thing that Web Page Test reports, which is the URL-specific field data for that URL as far as Google is seeing it. The ultimate source of truth for the SEO impact and for the Chrome User Experience Report from the search perspective is the Google Search Console. And it has a Core Web Vitals section on the left nav, which will give you a display of how many of your URLs are passing the good threshold, the 75% in all three metrics. How many need improvement and how many are poor. And then you can dive in and it will actually tell you which specific URLs and which of the metrics it is having problems with. Is it CLS? Is it LCP that is causing issues? Either in mobile or in desktop. And then kick it over to Tim.
Yeah. So now that we've kind of established like what they are, how you can measure them and stuff, we wanted to give you a few examples of stuff that we're seeing pretty often in the real world. So this is a test for leading home improvement retailer. And we're looking at the film strip view here in Web Page Test. So what we're looking at specifically is we have the layout shift stuff highlighted. So at the one at 18 seconds there, you see the red box and you see the information underneath that says that this individual layout shift is 0.228 of the 0.228 that layout shift window has. And this is layout window 4 in this case. So that's our largest shift window. So this is the one that we're going to get graded on from this perspective. And this shift is not only just the largest shift in that window, but it is the entire score. So if we can fix the shift, our CLS score should go down significantly and we move on to whatever the next size window is. So digging into this, if we look at what's going on with that image popping in, this is the HTML on that image itself. Like we've got our class, our alt, and the actual source for the image. But there's something that's missing here. When the browser is constructing a page, it's getting all of the HTML, it's getting the CSS and JavaScript, and it's trying to lay all of that out and preserve space where it knows things are going to be coming in. But from that initial HTML, it has no idea what size the image itself is. Fixing it is simply adding the height and width attributes in this case. Now, due to some recent changes in browsers, spearheaded in part by Jen Simmons, the browser can take this height and width information and pair it with the CSS information that it has and say, okay, I know the size of the image. I know how it's styled. I can lay this space out in the page, and when the image comes in, just plop it into place instead of having to lay it out and then the image comes and shifts everything down. So in this case, adding the height and width attribute to that image eliminates that shift altogether. Another one that we see very often is with largest contentful paint and lazy loaded images. So this is the view from a vitals page that I think Pat literally pushed the publish button on yesterday that we're starting to use for more diagnostic information for core web vitals. Right now, largest contentful paint being our first stab at it. And so what you can see here from the 3 screenshots is that the largest contentful paint is this image that's highlighted in green, and it occurs around that 17.4 second mark on a 4G connection, which is obviously much, much later than we'd like it to. Below that on this page, we start to surface some of the we collect all of the information in the JSON data around those largest contentful paint events. And we surface some of the more important stuff right away in a summary. And so the thing that jumps out here is we've got the image source, we've got the size of the paint and all that kind of stuff. But the outer HTML is interesting because you can see these lazy auto sizes and lazy loading classes on there. For lazy loading images, a very common approach to that is to use a JavaScript library. And in this case, something like lazy sizes. And what happens is the actual source on the image itself in the HTML will not be existed. Basically, you're using a data attribute to store what the image itself is going to be. JavaScript runs, sees, okay, this is a lazy loaded thing. Let me figure out what the right size is and let me pull it in at the right point in time. So because if we go to look at the HTML, that's exactly what's going on here. We've got a class lazy load. We've got our data attributes, which are defining the different images and what sizes potentially those images would be pulled in at. But there's no source attribute. So there's nothing here for the browser to see. So when the browser is going through and making its initial requests, it has no idea what that image is until that JavaScript has been downloaded, parsed, executed, and only then can it go and make the request for our hero image. Thankfully, nowadays, lazy loading is supported natively, at least in a few browsers like Chrome, Edge, that kind of thing, Firefox. And so we can add a loading attribute to tell whether or not we want it to be lazy or not. In this case, I've got the lazy property there just to demonstrate it. But because this is a hero image, we wouldn't want to use lazy. We'd want to probably have that out entirely so that the browser can request it right away. Putting that lazy attribute on it is going to mean that it might delay the request a little bit, and not be ideal from a performance perspective. But we can use that native lazy loading where we want it. We can move the source back into the source attribute instead of those data attributes and use the source set one to tell which different sizes we have. So now we have, and I added the height and width too to avoid the shift. But now the HTML, the browser would have everything it needs to be able to immediately make the request for the right sized image, pull it in right away, instead of having to wait multiple seconds for that JavaScript to arrive and execute. So in this case, when the test ran it with like this kind of faked in there, it took the LCP down from like 17.5 seconds down to like 4.5, I think, which, still some room for improvement, but significant improvement right away just by some basic HTML. And so, yeah, oh, go ahead.
Oh, no, I couldn't remember if this was me or you.
Yeah,
but...
no, it's okay. So that's kind of where we're at. Like as Pat mentioned, the change is actually coming now in June. We have May here because this was a pretty recent update from Chrome team. But basically, here's what we kind of know about it. We know that it's going to be a positive ranking signal, meaning if you don't meet these thresholds, it's not like you're going to get like plunged down a couple pages, right? And it's also going to be like a boost if you meet the good criteria for all 3. It's not going to be you shoot to the top of page 1 because you did it. But if you're up against the page with comparable content and comparable quality otherwise, the fact that you meet all of those 3 web vitals is going to give you a bit of a bump over the competing page. Those pages, those URLs are grouped by similarity, as Pat mentioned, inside the Search Console being the best way to look at that. And again, just kind of to reiterate on the geography side of things, we actually, You can collect Crux data, Chrome user experience data by country. They do have a breakdown by table, but we've seen nothing publicly disclosed yet to indicate that they're going to look at that geography breakdown. And in fact, I'd be a little surprised if that happens right away. There's some limitations right now from a privacy perspective where, if your traffic from a particular geography isn't above a certain threshold, Chrome won't even report it in the Crux data at all. And so I think because of that, I think it's quite possible that likely even that for now, at least, they would be looking at your aggregate scores for whether or not you meet those good criteria and using that as its indication. Looking at the data from the month of February, last time I ran this for the top 100,000 URLs, sort of to Pat's point on LCP, it is one of the two metrics that we see more organizations struggling with right now. First input delay, everybody's looking pretty good. That metric's a little generous. The Chrome team is looking at, like I said, finding ways to improve that, also potentially changing the threshold there. So if you are in a situation where you're in a good criteria for first input delay at your 75th percentile, maybe start looking at either your 99th percentile or start looking at like a 50 millisecond threshold instead of a 100 millisecond threshold to give yourself a head start. CLS, probably because it's such a new thing, layout shift is the score that is hitting the most people the hardest. That being said, this was also done before Chrome started to change the way the CLS score is reported. So we don't have data yet to be able to say how significant of a difference that's going to be for some folks.
And it's also worth noting or keeping in mind that the targets that the Chrome team set are based on the field data. And so as the world improves, the targets will improve as well. So even once you get to good, don't assume you can coast forever. The world will catch up to you, and then all of a sudden the target will move and you'll need to focus on it again. But they have committed to having reasonably long update cycles and lots of heads up and things like that.
Yeah, they're not going to pull a rug out from under you right away. So we mentioned the SEO juice, but there's other reasons why this is important too. Brand reputation may end up being at stake at some point. Chrome has experimented with how do they use this data to surface whether a page is historically fast or slow. So right now there is a feature in Chrome and Android. It's really tucked away and hidden. You have to long press on a link to bring up this context menu, but it'll use that Crux data to tell you, yeah, this is typically a fast page or not. And they say right in the post that they will be experimenting with labeling and other parts of the user interface in Chrome with the goal of sort of surfacing this. And talking to a few folks on the team, I fully expect this to become more and more prominent over time. I think it's going to be like a lot of things Chrome does from a UI perspective, where they take baby steps and slowly make this more and more prominent. So, maybe we start to see this, more prominently in Chrome. I wouldn't be surprised if at some point we start to see some sort of a fast or slow label in the search results themselves. Like, I think those kind of indicators should be expected to be coming. So it's not just the SEO boost, but the brand reputation side of things.
Particularly
We've also,
oh, go ahead.
But I was just going to say really quick, we've also seen data coming in from organizations who are tracking these metrics that show like, hey, when they made an improvement to LCP or CLS, they saw significant improvements in conversion and page visits and stuff. So there's a demonstrable user impact as well.
Yeah, so I mean, that speaks to how well the metrics are representative of the user experience. And as Google sort of walks back away from AMP, I fully expect, like, there's the AMP lightning bolt in search results to tell you which pages are AMP. I fully expect at some point that you're going to see that migrate to be more of a speed indicator in search itself as well.
So if you want to keep up on this, because it is, I mean, in the grand scheme of things, this is all still very new. And, we're constantly seeing improvements to these metrics. I mentioned the CLS change. I mentioned they're playing with first input delay and what to do there. They've made some changes inside of Chrome to better handle things like invisible, elements and stuff like that, triggering paint events too early. So it's constantly being iterated and improved on. Get in touch with Annie or Nicholas on Twitter. They're both very active, very involved in the whole metric process. And they're great people to talk to try and understand more, or if you're running into something that's unexpected. or filing a bug, they are hungry for any actual information they can get from people in the real world where they're running into issues, with any of these metrics that are unexpected. This is all super important so they can continue to fine tune, because without that feedback, they're it's all going to be based on whatever analysis they're limited to be able to run. So they need feedback from organizations. So if you do run into anything with any of these metrics that seems amiss, or you need some clarification, get involved. They're looking for that feedback for sure.
Yeah, and if you look, the Core Web Vitals has a change log that tracks when things change by browser versions, and they've been changing in Chrome 89, 90, because there have been sort of edge cases that they're finding and that people are reporting as they start to look at these metrics more and more, where the metric is misfiring based on what's actually going on in the user experience. And so filing bugs for those is absolutely critical, and generally ends up in them getting resolved and the metric itself improving for everybody.
I should point out, I guess, everything that I can think of that has been changed in those versions to handle things like this, or the change to layout shift, that all came from the user feedback like that. There's also just generally getting involved in the web performance working group, which is not just about the metrics and vitals, but tends to get into a ton of different performance information. Like there was an A/B testing one a while back. And the nice thing about this is you get like participation from different browser vendors, you get participation from different tool vendors. When it was the A/B testing one, they had Optimizely and Google Optimize and Adobe Target folks present. You get representation from developers at different organizations and consultants. Like you get a very diverse group of voices, which is awesome. Just to hear all the different perspectives, it's really interesting. They meet every 2 weeks, always with some sort of an agenda in terms of what they want to talk about. But this is where that early discussion happens around, what do we still need, and how do we standardize it, and what's missing, or what are the issues that we're running into.
And like lazy load, native browser lazy load came out of this group, for example. And that's it as far as the prepared presentation goes. So now it's free reign if you've got any questions or anything you didn't ask in chat.
Yeah, I think it was a wonderful session, and it's important for people to start looking at it from the user perspective. I mean, we have always been used to being okay with whatever we are doing in the house from the server side, and not really looking at what the ultimate user is facing. And if anything, anybody losing the customer, it's not going to be the somebody else, but it is going to be the company whose customer it is. So we have to look at that experience. I was reading some time back somewhere that Walmart said that around 1.5 seconds of improvement in the page loading increased their business conversion by 2%.
Yeah, Tim actually helps run one of the aggregate sites that collect sort of all of those industry reports, but there's hundreds of cases where you see the performance work having direct correlation with the business metrics. I'd say also from the sort of the traditional what we serve, availability, monitoring kind of side of things, one of my favorite things in web page test is the single point of failure tab, the SPOF, where you can black hole third parties and see what impact it has on your site. And it's particularly interesting to see when like Google Tag Manager or a third party sort of marketing thing that you put on your website, if that ends up becoming unavailable, from the user's perspective, the browser will show a blank page for 60 seconds until it times out that request, making the site itself effectively completely unavailable, even though all of your monitoring is going to say, no, my servers are up, the site's available. And so that's kind of the full browser end user measurement of the experience becomes critical there as well.
There's a question.
Questions about TTFB and if it's redundant. And so I'd say it's not. So there's, and especially how it impacts SEO. TTFB itself, as far as I know, does not impact SEO. What it does impact is the crawl rate. So Google, the indexer will crawl more pages. It kind of has like a time budget to crawl your site. And the faster your site responds, the more pages it's going to crawl. And so that's kind of, and the fresher the content will be if it's changing content, for example. And so that's where TTFB impacts search, if you would, not necessarily the rankings. It's definitely a redundant measurement as far as a slow TTFB will cause a slow LCP. So it's included in the LCP, which is kind of the ultimate end user experience. But it's still important to know because, like we mentioned, if you have a slow TTFB, everything else is going to be slow. There's nothing else that can happen.
Yeah. So from an SEO perspective, I think it was before, like for a long time, people have tried to figure out like what performance metrics matter to Google, because we've heard plenty of times that like, performance mattered to them in a search engines in one way or another. Core Web Vitals is the first time we got some transparency around that. Before that, there had been studies, and I know there was one prominent one that tried to correlate performance metrics to SEO rankings, and TTFB ended up being the highest correlating metric. Probably though, because of exactly what Pat just mentioned with the crawl rate and stuff and the fallout from that versus actual SEO ranking boost. And now we know like definitively that it is not one of those three metrics. So from the SEO side, like Pat said, like it's, it should be considered a supplementary metric. So absolutely one you need to watch and kind of helps you debug why maybe like LCP is slow or something like that. But it is certainly not the only thing that folks should be looking at, or even the primary thing in most cases.
And even then, I'd probably watch the crawl rate in the Search Console more than watching the TTFB, assuming it'll impact the crawl rate, because changing hosting and a whole bunch of other things can also cause the crawl rate to kind of go way askew. Oh yeah, and Tim posted in the chat, the WPOstats.com is the site that collects. I was having a brain fart and couldn't remember it, but the studies. If you ever need to see sort of what studies have been done about correlating performance to business metrics, it has most of them for like the last 10 years. Is there a way to capture web vitals for user journey pages? Sure. So web page test, you can do a script and do a user journey. The URL level data that comes from the field from Chrome will be however the user got to those pages. So if they got to a product page through a journey, the data will be there. Where things kind of get complicated is if you have a multi-page app, then a user journey in Core Web Vitals largely makes sense because each one is a navigation. If you have a single page app where the journey through pages is completely done on the client, there is no new navigation. So LCP won't get reported for that, for example. And there is no LCP measured for bringing up a product page that is within an app that was already loaded. CLS is that it used to be in aggregate across the whole journey. Now with the windowing, you will get a CLS for just that navigation. You won't get a FID from the field because the first user input probably happened to open that that user journey page in a single page app. But if it is multi-page app, sort of traditional HTML published stuff, then yes, you can get everything for a full journey as well.
Yeah, so in the field, if you want to measure those kind of key milestones, that's kind of on you. They're not going to be the web vital stuff. That's going to be on you doing things like element timing to be able to say when a hero image gets loaded or something like that. And then synthetically testing this kind of stuff, that's where I think that crux data that gets displayed on the web page test results comes in really handy, particularly on the CLS side of things, because you'll frequently, or at least I've frequently seen a very significant difference between what a CLS score shows in the crux field data versus what a synthetic test shows. And that's almost always an indication that the CLS is being triggered by something that happens after that initial page load. And to Pat's point, that's where you're scripting, like have it interact with the page. Like the screenshot I showed with the different windows was actually a test where I injected a script in web page test to tell it to scroll all the way to the bottom and trigger all the infinite lazy loading stuff. And the CLS score spiked significantly over that initial load. Or, you know, if it's an SPA, scripting it so that you're clicking around and navigating between, you know, category, like an e-com site, moving from a category to PDP, et cetera. So that's where that crux data can be super useful. If you see a big gap, it's probably an indication that some of that CLS is happening from other interactions after the load. And that's absolutely where you want to script something and, you know, try to get a closer picture of what's going on.
Yeah, scrolling a news article, for example, where the ads kind of get dynamically injected while you're reading it and it jumps all over the place is a very different experience than just loading the news article initially. And so if you're only measuring the load initially, you're probably missing out what's actually triggering the field
Because I guess we didn't really hammer that home, but it's a good thing to keep in mind. Crux data is looking at from the moment that page, you request the page, to the point where the tab's visibility state changes, meaning there was a browser hard navigation to a different page, or the tab got closed or something like that. So anything throughout that entire time until that visibility state changes, gets pulled in from a CLS perspective and LCP potentially. But CLS in particular, like that's all get pulled into that particular one session. Whereas data that you might be collecting from your own real user monitoring probably doesn't do that. It probably sends back a beacon at some point after the page load process. And synthetic tests only going to run until as far as you've scripted it. So you will see a mismatch out of the gate between those three sources, between what Chrome sees, what your real user data shows you, and what your synthetic tests show you. And understanding that that's how it's measured factors in there as critical for helping you kind of diagnose what on earth is going on.
So the Core Web Vitals measuring a 3G client. I'm not sure where the 3G came from, or that's what they were using when they set, like Lighthouse generally built their targets against a 3G client, but the Crux data and the Core Web Vitals data measures all of the user traffic regardless of the connection speed.
Yeah, and you can look at, like, again, that's to the point, like Crux data can be broken down by connection types, you can see, but only if there's a sufficient amount of traffic. Like if you have lower than that threshold, that privacy threshold of 3G users, it actually kind of gets filtered out. So yeah, I think that's, again, to Pat's point on that field data, try to line up your field data with your tests as best as possible and see like what is actually representative.
Yeah, now what I don't know, speaking of optimizing for mostly desktop users, the mobile Core Web Vitals will go into the mobile first search indexing. And so I'm not sure, like web page test itself, for example, is mostly desktop users, and the mobile Core Web Vitals for web page test kind of suck because it almost has no users. I don't know if what impact that's going to have. Maybe it won't meet the threshold because the mobile scores aren't good enough for the mobile first indexing that Google does, where even though it performs well on desktop, I don't know what impact that's going to have on SEO. And so we'll kind of have to wait and see largely for that.
Hey, Patrick and Tim, I had one question. I know how the performance metrics is getting evolved with the Core Web Vitals. My question was on what kind of metrics do we need to measure for applications like internal, take an CPQ or a B2B or CRM application? Typically, as the industry standard, what metrics from a performance point of view do we need to measure?
I mean, if you're doing the right thing and you're optimizing your performance metrics for the users, not for search, the best thing that you can do, sort of in all cases, if it's an application that you control, is to add element timing and user timing marks to the core events. So like in the case of Twitter, their main metric, for example, is time to first tweet, when the first tweet gets displayed. For a lot of mail apps, it's time to inboxes, when the inbox actually shows up. And so if you control the app, even a B2B app, what are the key things that your users are trying to do on your site, and measure those explicitly. And if you optimize for those, you're going to be doing the right things. If it's not something that you control, or it's not an app that you sort of have a lot of context about, the Core Web Vitals is kind of the state of the art right now for agnostic measuring of general web performance.
Thanks, Patrick.
Okay, great. Thanks, Patrick and Tim. It was a wonderful session, and I think our participants have been able to also get quite a lot of interesting insights. And this is just a journey starting. I think they can be in touch with you people. You have given your Twitter handles, so it will be great for them to connect with you and carry on the journey. We'll also hope to see sometime together again. And yeah, it's wonderful. The recording will be processed and will be available in both excelintro.com and devopsindiasummit.com for people to view it whenever they want. And those, I think there were 82 registrations. So all the 82 people will get the link for that, so you can view it even if you have not been able to join here. So thanks once again, Patrick and Tim, for your time and this wonderful session.
Thank you.
Thanks everyone
guys.
for
This
coming.
was great. Thank you.
Bye.
Thank you.